Hi everyone, thanks for joining us. Today we're going to have a look at from the higher level 2022 paper, question 6, part I. If you've been following along, we're working our way through the short questions at the moment. We will get to all the other questions in the paper, but that's just where we are today. This is actually a really nice question. Before we get into it, I'll give my normal advice, which is if you really want to make sure that you know what you're talking about and you're getting ready for your Leaving Cert exam, the best thing to do right now is to take out pen and paper, give yourself a mini test, see can you do this question as if you were in your exam. Don't watch the rest of the video before you ever look at me giving you the answer, and see how far you go. See if you can get it out, see if you get some of it out, or see if you're totally stuck and you need to have a look at a sample answer or a video. That's the best way to know that you're actually understanding this, because it can be very easy to watch a teacher or myself do this out on your whiteboard and think it makes sense now. And I've heard this over and over again from students. It makes sense in class, but when I go to do it myself, I'm stuck. So try it for yourself, then come back and see how did you get on. Okay. If you got an answer out and you think you're right, you actually don't need to watch the video. You can check on my sample answer or the marking scheme, which are up on the website with this video. Okay. Yep, that's it. Let's get started. Let's have a look at what they were asking us to do for 7 marks in this one. So they have a tungsten cube of side 2 centimeters, has a resistance of 2.8 micro ohms. Always watch for these little micros and millis. Calculate the resistivity of tungsten. Okay. And they even drew us a little cube and everything on the exam paper this year. So I'm just going to add to that. Now, if they hadn't, or even still, I probably would draw a cube on my answer sheet just to have the visual to go with it. And it's saying the side is 2 centimeters. And since it's a cube, we know that it's 2 centimeters here, and 2 centimeters tall, wide, and deep, I guess. And that's going to make things easier in a second. Okay, so we've got our cube. Granted, it's a tiny metal cube, really. It has a resistance of 2.8 micro ohms, and you are asked for resistivity. Okay, now resistivity and resistance are different. So what you might think to do, I forgot to write the page number here for this, but I think it should be in your formula tables. Resistivity uses the symbol rho. It's also used for density, but they're hardly ever used at the same time. So it should be pretty clear which they mean, given the context. If we're talking about a resistance question, well, it's a resistivity. So what we have here is resistivity is equal to resistance multiplied by the area of whatever it's going through divided by the length. Okay, so what you may have been more familiar with is a question something along the resistivity of a wire, and there's an experiment related to that as well, so you might have used that formula in that calculation. You probably should have, and you're kind of generally thinking about it like a wire. So it's got a length, and you might have used the term cross-sectional area for this bit here. But just because you're familiar with this kind of cylindrical wire doesn't mean you can't use the exact same thing here with our cube. Okay, and that's what we're going to do. So I might just remove my little drawing there to show you about the wire, like just so you don't get confused. It's just my way of saying, kind of making it familiar to you. Where might you have seen this before? So we're going to clear this away because I need a bit of space with my big writing. Okay. The next thing I would do when I'm in my exam is I would write down the information that I already have from the question. So I have my formula, and you probably, you can have a look on the marking scheme, but even just writing the formula is an excellent start, okay? So let's start with resistance. Got a resistance of 2.8 micro ohms. So that's capital R, 2.8 micro ohms. Now, I'm going to straight away get rid of that micro because that's going to throw me off later if I don't. And I know that that's 10 by 10 to the minus 6 ohms. And you can check them out in your log tables if you need to. I'm fairly sure it's page 45. I'm going to double check for you right now. I kind of know them, and you probably would know a few of the common ones. Yeah, page 45 will tell you, if it's 10 to the minus 6 or 3's milli, for example. Just put it here in brackets anyway for you. You'll get to know that, and by the time you come to the exam, you'll be flipping straight into page 45 without even thinking about it. So we have our resistance, we actually have our area. Let's see if I can use a different color just to make this a bit more obvious. This is our cross-section area now, let's say. It's just one face of the cube, okay? So if I have one face of the cube and I know the cube is 2 centimeters by 2 centimeters, I can figure out the area because area is just length by width. Before putting in 2 by 2 here and getting 4, I'm going to turn those centimeters into meters, okay? Because it's harder to convert it after. So that's my 2 centimeters, it's 0.02 meters. And maybe just so you know where I'm getting that from, that's this guy. So 2 centimeters was given to me in the question. And if I do that out on my calculator, and this is why it's harder to convert because you end up with lots more zeros. 0.0004 meters squared. So you'd be gone off a bit if you just went straight into centimeters. We want everything in meters. Just so you have that's where I'm getting that from. 2 centimeters, 0.02 meters. Okay, hopefully you're comfortable enough with that by now. And if you're not, that might be a question that you have. If you're not totally clear on that, let me know. So I've got resistance, I've got area, and I have length as well. That's 2 centimeters as well. So if you like to think of this as a really weirdly shaped wire, it's one of these. Okay, so it's 2 centimeters because it's a cube. And of course, I'm not going to write 2 centimeters. I'm going to go straight to meters and write 0.002, sorry. Sticking in too many zeros, meters. All right, so I've got 3 things. And the question asked me for resistivity. If I'm going to go back here now to my equation and say, I have that, I have that, I have that, I have resistance, I have area, I have length, and I need resistivity. So this is a really nice question in my opinion, because there's nothing, the question gives you everything but one. You're not trying to do 2 steps or anything like that. So I'm going to rewrite my formula. So I have it for myself. I've got resistivity is equal to R times A over L. So my resistivity equals to 2. I'm just plugging in the numbers that the question gave me here now into the right spaces. 2.8 by 10 to the 6 is my resistance. I worked out my area was 4.0004. Now you could, if you felt comfortable, you could change that to scientific notation as well, but you don't need to. I'd say most people are happier just to make sure you're not missing a 0. And your length is 0.02, 2 centimeters, 0.02 meters. And you can put it all into your calculator and you should end up. Now, if you're struggling with the calculator a bit, it's getting you a little bit. Let me know that as well, but I'm just going to put on my calculator, I would multiply the top 2 and then divide by the last one, okay, just in case that's something that you're not sure about. And I ended up getting an answer of 5.6 by 10 to the minus 8, and then your units, okay, and I'm going to talk about the units for this one in a sec. My units are ohm meters, okay, so the difference between resistance and resistivity is resistivity will change depending on how long the item is, the wire or the block or whatever. So you have to think about the meters in the answer. Okay, so this is your answer. You're done for 7 marks. I'm going to just do a little bit. It's a fancy name for it is dimensional analysis, but really what I'm doing is showing you how did I know what that unit was. Okay, I'm going to stick with blue, and by the way, please let me know if anyone has, oh, I went for purple, anyone has a problem with the different colors. I have a sample answer done anyway in just kind of plain black and white, so it should be okay. But here I am on my resistance, right? I'm going to show you how I knew that it was ohm meters, or how you could tell if you forgot in the exam, because you mightn't always remember that resistivity is ohm meters. It's not one we use as much. You should know resistance is ohms, area is meters squared, and length is just meters. And all that happened when you have those units, I'm going to put them a little bit over. I don't have very small writing. So I end up with ohm meters squared divided by meters. And sure, we should know that if I have a meter underneath, I can cross off that square and I get ohm meters. Okay, that's not something that you ever need to write out on paper. The bit I just did in purple, you're not going to be asked to do that in the Leaving Cert paper. I just want to show you how I got my ohm meters. That's not just something I had to learn off. I was able to figure it out from the equation. Okay, So that's not a bad question. It took me longer a bit of time to do it, but that's because I'm explaining it, you know. So if you're doing that in the paper, as long as you remembered your equation or you were able to find it in your log tables, you would be set because you have everything you need to just plug it into the right places. You might have got caught with changing your units, and that might have sent you an answer that was a bit off. But otherwise, it's not a terrible question. That said, if you have questions, you didn't quite get one step or you didn't get any step at all and you were very lost and confused, please let me know. As always, if you have other questions that are not just on this exam paper, and if they're on a different paper, if they're from your textbook, if they're just something you were wondering about physics that you're not too sure about, let me know and I'll get back to you in a couple of days and hopefully solve a problem for you. Okay, so thanks for watching and I hope you found this useful.